It's throwing an error. Not sure why. Hey, good evening, folks. It's a wonderful day to kind of introduce to you something new, something that we haven't seen before. And for today, I'm going to introduce Jina, and Susanna from Jina is going to talk about, how to build your own AI-powered search engine. So before we get started, right? So I just wanted to show you what are you going to learn today.
And then we basically have this kind of Jina box as a kind of front-end playground. And then you can basically drag and drop your images and basically search for similar images. So notice that this result is purely on Google, Google Big Transfer. It's trained on ImageNet, right? It's pre-trained on ImageNet or whatever this public dataset they have. So it's not trained on Pokédex or Pokémons, right? But still, it gives a reasonable result. So that is also very good because Jina, this is how Jina helps you to quickly bootstrap the first prototype by using those pre-trained models, right? And so basically, you can also do some very fancy things like you can also capture from the.
As you saw, this was such an easy way to kind of build this up. So Susanna from Jina is going to kind of walk us through, how do you kind of build that up and kind of tell you more about Jina. Over to you.
Hi. So, hello everyone. I'm going to share my screen here. So, can you see my screen now?
Yes, all good.
Okay. So, okay, let's start. Oops. So, neural networks are everywhere, but neural search is just coming through. And that's where we're going to be talking about today. So, welcome to everyone. I'm happy that you're here. And I'm Susanna. I work at Jina, and we're going to be talking about neural search today and a little bit the basics of Jina and how you can use it to build your own neural search. So let's see. This is the content. So this is the overview of how we're going to do it today. We're going to be talking about search, about neural search more specifically. I'm going to tell you a little bit more about what exactly it is because it's a very new topic, I would say, so there's not that much information about it and it can be a little bit of sometimes misunderstanding. And then we're going to talk about how we can connect that with Jina, how it's the data structure of Jina. And we're going to also see two examples. One is going to be the hello world. So it's a very basic one, still very powerful, but a little bit basic. And then we're going to see an extension of it. So it's going to be the same hello world, but extended with something that we call query language. And then you can see also how can use this thing. So this is the overview, the search, the data structure of Jina, and then two examples that all of them we're going to be building on top of each other. So it will be a smooth transition, I hope. So let's start. The first thing we have to talk about is search. So what do I mean by this? What is search? Of course, this is not new. Google has been doing it forever, and you use search every day, everywhere. You use it in Twitter and LinkedIn and Instagram, everywhere. But that's not what we're going to be talking about here today. We're going to be talking about neural search, and how does that differentiates with normal search. So before, without neural search, what you had to do any kind of search, you needed to create some symbols and some, you needed to define everything. So if you had, for example, a shop where you had different items to sell, for example, sneakers, you will need to specify the brand, the color, and if it has any synonyms that can be used to each other. So the synonyms that can be used to the same item. And then that's a lot of work. And on top of that, you will need to do that for all of them. And what if they call it a little bit different in another country, even if it's the same language, but what if they don't call it sneakers, they call it different. So you can see it gets very complicated. So that's a lot of work. And it's not just a lot of work, it's a lot of work that is unreliable because it's so much things to do. It can be very fragile. Something can go wrong, and it's such a big thing that it's hard then to check what happened. And even that, even though it is more complicated and it can be very fragile, it can be that complex. You know, it's not what we want to go now with this neural search area. And this is what we're going to be talking about today. Not just the normal or the standard way of search, but what is coming, what is next. So neural search is a new topic, it's kind of new. There's more and more people talking about that. So let's define it a little bit more. So neural search can be used, and it's used for all kind of modalities or every kind of data that you can think of. You can use it for text, you can use it for images, for audio, for video. You can use it for everyone that you think, and you can also use it to do something that is called cross modality. So you can use several of them in the same example. What do I mean by that? Let's say, for example, you have here in your Google phone or Google Photos, you have two types of modalities here. So one is the text, so you want to search for a cat on your library, and what you expect to have as a return is many pictures of a cat, obviously, because they're awesome. So you have two modalities here, text and images. That will be more complicated to do before, and also if you want to extend that and you want to be not just to say a cat, but if you want to be more specific about the setting that you want with your query, you can also do that with neural search. So in this case, of course, to do that before with symbols and with rules, as we saw in our previous little example of a shop, it will be much more complicated. And it gets even worse if you want to now do something like a combination of two languages. So in this case, for example, this will be a cat in Christmas, or as here, but now I'm using two languages, which of course makes everything more complicated. Then you can do that with neural search. Another thing you can do with it is something called multimodality. So let's say now that you don't have only the image, but you also have text, and you want both of these things to be together and together be the query. So this is an example from this dataset, the Fashion 200K dataset. Of course, you can use it for whatever, but what is happening here? Let's say that we have this query as before, that's, for example, this text, but now I also have this image. So I want to somehow specify that I want something similar to this image, but also with these kind of attributes. So I want to replace the length with this new length. I think the most obvious one is the last one, so this row. So we have this jacket that is a black jacket, and you have it as a query, and you say that you want to replace this with the color beige. So this is what you expect to get. This, of course, will be much more difficult to do before without neural search. So this is why more people is talking about it today, because it's very powerful and it's very useful nowadays that we have so much data. You can also do not to combine two types, or not just text and images. You can also, of course, just look through images. This is one example that we have in our GitHub examples, actually. So you have when query as a GIF from Tumblr, and then you have similar results also from Tumblr in this case. So as I say, you can have different type of data. It can be text, it can be audio, video, or a mix of them. And this is what exactly we want to do. And this is what Jina is trying to achieve. So what we're trying to do is to create a framework that is trying to help you to get little think by yourself, but to use this framework that has a lot of powerful things already implemented on it, and you can focus on the idea that you want to achieve instead of the small details that you are thinking about. And for that, we need to see then a little bit of the structure and the flow of it. So this was before what neural search in general is, and now let's try to see how we could connect it in Jina. So first of all, we have our data, whatever data it is. It can be text, image, audio, video, it can be whatever. Let's say that we have text. That is the first one. So let's say we have a text. Let's say we have a document with all the text. It can be that it's very big. So the first thing we need to do is to make it into smaller pieces. It's always easier to work with the smaller pieces. So the first thing is always to craft it, we say it. So let's say to modify it, to make it a little bit smaller. So we take the document and we divide it into smaller pieces or chunks. So we take the document, we craft it, and the result is going to be smaller pieces of that document. Now that we have those smaller pieces, there is still in the original format, right? The only thing that we did was, let's say, just to cut the text, but it's the same text, just smaller. But now we need to encode it because we cannot work directly with this kind of type. So we need to encode it into vectors. So then we have our document, we make it into smaller pieces, and we take those small pieces and we convert it into vectors. And then those vectors, we save them here. And then we need to not only save the vectors, but we also need to save the original document. Because at the end, what we want to return is the document, right? We don't want to return the user just whatever random vectors. So we need to save both. And this is the first part. This is for the indexing part. This is how we modify and save our data. And then for the query time, now when you want to make question, let's say now you want to ask for something about the song or the text that we were talking about before in the indexing, then you need to do something very similar because your query is anyway in the original format, right? So you have your original query. You also have to craft it into smaller parts. You need to encode it also into vectors and then save it. And then when you have it like that, then you can do whatever kind of whatever metric you need to retrieve the one that you want. I think that's going to be clear in the next slide. Let's say we have this song, the best song ever because it's about cats. So this song is called "Can't Hug Every Cat." So the first thing we need to do is divide it. So then we're going to have different parts of the song. So we're going to have the title, for example, and this part. And we need to save this into a vector. So we need to encode it into a vector. And we need to do the same for the song itself. Then we have this data already translated or encoded into vectors. And then we have our query. Now let's say that this query, if I don't know the exact name of the song, for example, and I want to look, I kind of remember that it's called something like that, I can have the cats or something like that. So this is my query. My query is not exactly the same as the original title, as you can see. So I am guessing that when I encode it into a vector, it's not going to be the exact same thing. This vector is not exactly the same as this one, but they are quite similar. I will expect that because the string in itself is quite similar. So then after I do my crafting and I do my encoding, then I can check which of all the possible of all the other possible vectors that I already had stored in my database, it's the most similar one to my query. So we do this, the shortest distance of between the vectors, and then the shortest. And this is what we can do for all types of data. You can also do this, and this is how we usually do it for images and video and whatever. This is the same principle for all kind of data that you have. And now let's see how that translates into the Jina world. So in Jina, we have something that already takes care of much of this stuff, and this is the flow. Think of the flow as the abstraction of this indexing and query time that we talked about before. The flow is going to manage this for us, which is nice. It's a context manager, and it's form of pods. The pods are the ones who the flow is going to manage the pods, and the pods are the ones who are doing the task that we said before. Think about it as the brains of Jina. And those little guys are the ones who are actually doing the crafting, for example, or the encoding. So the flow is the one that is in charge of managing that the pods are doing their job. And the pods are doing the actual things. Now, the pods, they have another thing. They have something called executors. And the executors, because we have different things that the pods can do, right? It's not the same to do crafting than to do encoding. So we need to have also a different help for someone else that is also specialized in that. And that's where we have the encoders. So we have encoders that are specialized in all those jobs that you will usually need. So you don't need to do them by yourself. So we have these encoders, these executors right now. I'm going to talk a little bit about them and then tell you what you want to do if you need something different. So the first one that we have is a crafter, of course, because it needs to be what we said before. The very basic thing that you will going to need is to craft it, or segment it. You're going to take your document and make it into smaller pieces. Then we also have the encoder that is going to do what we said before. It's going to represent this little piece or this chunk as a vector. Then we have the indexer. That is the one that is going to be on charge on saving in the indexing time and to retrieving the vectors on the query time. So this guy is doing those two things. Then we also have a ranker that we didn't talk before, but this is going to sort the results to see which ones are the actually best ones. Then we also have, recently we introduced an evaluator that evaluates the predictions that some of the models can be doing. Oops. So those are the ones that if you go right now into our GitHub, you're going to see. But we are an open source company, so if you have any more ideas of things that we can include, we're always happy to hear from you. And you can also always add whatever thing you need. We don't have there yet. But just with those, you could already do a lot of very powerful things. But yeah, just to let you know that you don't have to be tied to this. You can always expand it. And this is an overview of what the things we already discussed. This is nothing new. I just wanted to make this slide to do a little bit of an overview of what we already said. So again, we have the flow. The flow at this moment is empty. We need to populate it with pods. In this case, I'm going to have two pods. So one is going to segment the document, encode it, and index it. And the other one is going to only index the document because, like we said before, I need to save not only the chunk or the encoded part that we created, but also the document itself. So after I do those two things totally separate, they're completely independent from each other, then I join them, and that's it. So this little part here is just like a zoom in of what will be inside of this. And inside of this will be our executor. In this case, as you can see, there is only one pod for this side. So there's only the executor here. So this is how it works in Jina. Now, of course, that's nice and all, whatever, but how do you actually put that into code, right? That's the cool part. So we're going to create a very, very simple flow. Works, under the hood. But what do you actually need to do is quite easy. You don't need to know any of these things that we said before. The thing that you need to do is to import the flow and make an instance of that. And just with that, you have your flow already. Of course, because the flow is a manager, right now it's empty, so it's quite useless because it's not managing anything. So the next step is to populate it with something, right? So then we need to add some pods. And how do we do that? We add the pods simply by saying .add. So you have your flow, and then you just said, okay, flow, please add this pod. And this pod, it's going to use this type of encoding. You can use whatever encoding you want. For this case, we're using the simple one. And I also want another pod. I want the one of a simple indexer. So in this case, we have our flow with two pods, one for encoding and one for indexing. And now that we told our flow what does it have and what are the pods, then we can actually use it to index it. So then with this flow that we just created, then we're going to index whatever documents that we want. And it's going to have like this kind of behavior. This indexing will happen using those two pods. Or yeah. You can also be much more complicated if you want. You can also add parallelization and sharding. As you can see, it's also quite easy. You just need to add the specification here, or you can even add your Docker image if you have it somewhere else already. So let's say that you have one Docker image like we have in one of the examples that you can check if you want. And that is already running. So I just want to use that already running image into my flow. So I'm just going to use it as one of the pods. And yeah, I can also set the host and maybe some sharding if I want to. But just so you can see that you can go from very, very simple as this one to much more complicated. And it's not that much difficult for you to specify this. So this is a very simple flow. Now, if you get to the hello world in our GitHub repository, you're going to see that to do the hello world is very, very easy, and you're going to get this as a result. So what is happening here? What is happening here is that, well, what is happening in the background is that you're going to use the Fashion-MNIST dataset, and you're going to then query some you're going to take some random queries like these ones. And from those random queries, you're going to get the best results. And this is what, if you run the hello world example, this is what is happening. Of course, to me, that's still not very useful because, yeah, okay, I have all those images, but usually what I would like to is not just to see all the data set just divided, but usually I would like to be able to specify that I only want, for example, the shoes, or I only want to see the dresses. I think that's the next obvious step, right? So that's what we're going to actually be focusing on now. And for that, we use something called query language. What we're going to do, this is the plan, just so you know kind of the overview. We're going to download the data and the labels of the same Fashion-MNIST dataset. Then we're going to create our flow index. So I'm going to show you how you can do it, not only with Python, but also maybe with a YAML file. If it gets too big, maybe if you have too many pods, it's not the best to add it directly in Python. We're going to create the indexers for the category. So we're going to see the bags and the shoes and so on, and then query. I think it's way easier to see it on code. So I'm going to show you the code and walk you through how that is done. But also, I'm going to have in this presentation, I'm going to have all the screenshots of the parts of the code that I will be talking about. So if you have any doubts, you can just check it and they're going to be there. So all of them are going to be here, but now let's switch to the code. Now, I know this is a lot of things you haven't seen before, so bear with me. Let's try to just focus one step at a time. So this is our main. This is where we begin everything, right? First thing that you can see here is that we are getting our targets. This is the data that we're going to be using. We just download this data, and the storage in this is our target. So this data is just the Fashion-MNIST dataset. We have the index label and the query labels, and then we have the index and query data itself, not the labels, but the data. So we have those 4 things. And now that we downloaded them, then we can start indexing. So we go to the index part, which is this next step. We go to the index. And as you can see, this is quite similar to what we saw before. We also have a flow, but the difference is that we are not specifying the pods here as we did before with Python. We're instead saying this is a YAML file. So you can also do that. You can specify your pods as a YAML file. So let's check what does that have. Okay, where is it? Here. So this is what the index YAML file looks like. As you can see, you have here that you're specifying your flow, and you say that you have these different pods. This is as the same as if you would do it with Python, and we just do it here. So you have those pods, and we have different pods. We have one for the encoding that is going to be doing what we already said. It's going to encode everything in a vector format. And we also say that we're going to have different pods for each category. So I have one for the shirt, one for the trouser, one for the pulley, and so on. So as you can see, I'm saying that I have this pod that is using this other YAML file. So then that's still not clear, right? I still have to see what this other YAML file is doing. But as you can see here, we have all those pods, all of them for each category, and then we join them all together as before in the example. But now we have to check what are those things, because right now to me it's not clear. So then we go to index, and it says here, and we check it. For example, this is boot. So this is the interesting part. Here, we're going to have these 2 parts. We're going to have one part for the index and one part for the search or the query time. As you can see, they're still quite similar because they kind of behave similar. The first thing we need to do is to use our query language, and this is part of like the code of this example. This, if you would check the original Hello World, it won't have this. And this is the only difference, that we are using this filter QL from the query language to check the label of the data that we're getting, and to check which kind of data is this. Is this as a boot, or is this a bag, in this case, or a code? They're all the same. The only difference is that the label itself is different. So we're just saying that we're going to filter whatever is the data, and we're going to look for this label. And then if you check then if you check again the flow index, you can see it was only that. It was the only thing that it had. Here I'm saying that if I want to use shards, or if I want to use a separate workspace and so on, but this was the only, like the core of it. If we go back to our original file, then we can check that we already created our flow, and we populated with different pods. We're going to have one pod for each category. And then we can use, now that we know how we're going to do it, we can start to index the documents. And to index the document, we have this little help here. Now, the only thing we're going to do here is actually to create a document, right? Because right now we don't have anything. So what we do is that we say we're going to create a document, which is one of Jina primitive data types. We're going to create one document, The content is going to be the target itself that we're handling right now. We're going to update its ID, and then we're going to get which label is it, because I need to know the label so I can then query. Then we the Fashion-MNIST, can never pronounce that. If you check that data set, you're going to see that the labels are just integers. So it's not really, this is not useful for me. You know, me as a human, if I say that this, whatever data I have right now is of type 5, yeah, okay, but what's that? So then I have this little helper here that I just mapped the integer to a string. And this is just what is happening here. So then we go back. So here in our index generator, so then we got the label and then we just mapped it to a category, you know, to have the string. And then we need to update the label with this category that we have. And this is again just with the document that we just created. You say that this is going to be in the label part, and that's it. This is how you created your document, and then you index through all of them. This was just the indexing time, and when you finish to do this, you're going to have this new thing here. This workspace is going to be created after you do your indexing, and then you're going to see that you have different folders here with all of those categories, and each of them have their own vectors in them. So they're also, since we separated them through different folders or different categories, then it's going to be super easy to query because they are already in different parts, right? So then if I go to my query, which is this part, I do something very similar. As you see, I also just create my flow. I say that I'm going to populate that flow with this part that is here, the flow query. So let's check it. I always lose them here. And this is almost the same as the flow index, as you can see. We're also going to have the same encoder that we used the last time. We're going to index all of them again, all of them with their different name, so one for each category. And then we're going to get them all together. So it is almost the same as this flow index. Oops. And now we can actually search or query through it. And we need to do again the same thing as we did before, because we still have to create these documents, right? This is also new data that is coming through. These are query data. So we also have to go through this. We have to create also a document. So we're going to do the same. We're going to have the label of that data. We're going to map it into a string. And this is where I am actually querying the data. So here, I'm going to check if I would like to check for dresses, I will do this. Of course, if I would like to look for something else, I will do this bag, for example. I'm going to say, if this document that I'm handling right now has this category, then you can continue and create the document. Otherwise, it is not necessary because I don't want to see it. So there's no point of me to going through that. I'm only going to get interested in these ones that match the category that I want. So if I run this, let's go back to our slides. So like I said, everything that I talk about right now is going to be in the slides. You're going to have this. You're going to have how to create the flow index and then how to create the different indexers for each category. Also in the slides, I have these other things you can do with the query language, and you can check them all here. There are, of course, many ways to do this. This example is just for us to see how we can use it, how we can use the query language. But of course, it could also be done differently. But it was for you so you can see it. And you can see here all of these other things you can also do with the query language. Of course, there are better ways to do it, but this was one that could show us, you know, the power that we can have with the query language. So then we have here, we say the same, exactly the same as before, and this will be our results. You know, this was with the dress, but like in this case, I said, where is it? If, for example, I wanted to not look for a dress, but for a bag, like this, and then I query to show me not the dresses, but the bags, hopefully. As in this case, you can see. So, oops, I think it's frozen. So yeah, I think here are the bags, and all the results are just bags. Okay. Oops. Sorry, it was a little bit frozen. And then you can see a little bit of how they compare. So this would be the original Hello World, what we had all of the all of the data, all of them mixed together and just query randomly through all of the categories. And then we can see how it will be with the query language when we can specify one category only, and then we're going to have the results for that specific one. So this was it from my side. If you have any questions, please let me know now, or you can also always ping me in Twitter, and you can also contact me and any of the team within our Slack that you can also check it here. And we're always super happy to have more people in the team that works with us. So yeah, if you have anything that you would like to ask me, let me know. Thank you.
Thanks a lot. I think there were a couple of questions that got answered as well. So the question was that, can they have like a single EC2 instance where all the processing can be done?
Actually, we were just working about that last 2 weeks. I was with another colleagues working with that. So I think we have some example of it in our GitHub. I'm not sure if it's there already, to be honest, but it is possible. We're just trying to run it now with Terraform and other things, but it is possible, yeah.
So it should be as simple as just running a demo app or replacing the dataset.
Yeah. Mhm. We also have some other examples that are similar to that, but not exactly, but they're run with Docker. So I think it is a South Park example. It runs with Docker, so you just run the Docker image, and then you're gonna have it running. You can check it. You can access the results either with Jina box, as the example you showed before, or with Curl.
Okay, so Philip has a very interesting question. So you mentioned about the encoders, that sit in the flow itself. So his question is around, can we compare encoders and possibly concatenations of different embeddings? How would I know which one is optimal? Or is there like a test prediction library that people can refer while building, the search engines?
So that's why we have also our evaluator, so you can check with different ideas that you have, and then you can check how that would compare to each other.
Is there something that you guys have internally that, or
The evaluator? No, those are there.
no, the prediction like which encodings are more suitable?
So I think we were talking about having some stress tests of different types, but we are still working on it.
Okay. Any other questions from anyone?
Or like I said, if you have something else later, you can always ping us in Slack
All right.
or whatever.
I guess no more questions. So thank you all for joining in today. Thanks, Susanna, for taking time. I think this was pretty interesting, pretty different from what we have been doing in our channel. So thanks for making time.
Yeah, thank you all for being here. I hope this was nice for you and you learned a little bit. Yeah, thank you.
Absolutely. Thanks.
Okay, ciao.
Bye.